One thing is biogas, right? We are not burning the biogas in the boiler. We are purifying the biogas and making it equivalent to CNG, and we call it as compressed biogas. Not only from vinasse, but also from press mud, we are making compressed biogas, CBG. And the biomethanated vinasse, and we are converting into a potash-rich fertilizer, which has around 4, if you operate it on C molasses, it has 20% potash, 40% organic carbon. On B molasses, it has 80% potash, the powder what you get. So I will show you the flow diagram, how the things work. I'll just get on to the flow diagram. Make zero liquid discharge, you can't throw the vinasse out. So what we can do with this vinasse? So this is the flow diagram. So this is what in India, in every distillery, this concept is getting in. Why? Because we are getting compressed biogas as well as potash. 50 plus installations have come up in India with this concept. And Raj Process holds the patent for this concept. So how the scheme works out? You have a sugar mill, you make sugar, you get molasses, right? The molasses, you store it. And you set up a distillery decided in such a way that spent vinasse stays in the tank for 30 days and it overflows over the tank. So in this 30 days, you get biogas out of it. Now this biogas, right? And other side, you have the spent wash. The spent wash is completely biomethanated. Biomethanated in the sense, the COD has completely come down by 65%. The pH goes to around 7. That means it's alkaline. So it's a fertilizer. You can throw it in the field, it's a good fertilizer. But in India, especially, it's not allowed to throw it in the field. You will have to make it zero liquid discharge. So what is the solution? How can you make it zero liquid discharge? So what we do with this vinasse, biomethanated vinasse, we pass it through the evaporator. We concentrate it up to 30% solid, right? So 30% solid, 30 bricks, and then we pass it into a dryer, wherein we use bagasse to dry it, to make it to get the powder solid out of it. The solid is called as dry powder, and then it is mixed with boiler ash or any press mud or bentonite to granulate it so that it can be used by the farmers and it can be used in the field. So what you get on one side from the biomethanated vinasse is potash granules, and from the evaporator you get the condensate, which will go to the CPU and you can use it in the process, right? And the biogas what comes out has 55% methane, 30% CO2, and it has 4% of H2S. 4% in the sense 40,000 ppm of H2S. Now, where to use this? Yes, primarily if you say you can use it in the boiler without any pre-treatment of the biogas. Now, if I would say that instead of using it in the boiler and saving the bagasse, rather I would prefer to use it as a fuel for the vehicle. How can you use it as a fuel for the vehicle? You need to remove the CO2 completely. You need to remove the H2S completely so that it can be equal to CNG, compressed natural gas. So this biogas passes through a purification system, H2S scrubber and a CO2 scrubber. And then you can use it as in the gas engine, or you can use it in the cascade to make CNG, compressed natural gas. So one thing is gas engine can give you power, and the second point is it can be used in the vehicle as a cascade. Press mud is also the another source. I will play you some videos later to show you how it can be done. So this is how, what all from raw spent wash, what all products you get. You get biogas, you get water from that condensate polishing unit, and you get potash, which can be further converted into granules. Now the concept, now I'll take you through the stages, how it all happens. In the biomethanated this spent wash, raw spent wash, which you hold it in the tank, it is called as a CSTR tank, continuous stir reactor tank, wherein you hold it for 30 days. There's a central agitator as well as lateral agitator. And then you get the gas, the COD get reduced by 85%, 60 to 65%, BOD get reduced by 85 to 90%, and you get pure biogas. Now this biogas can be either used in the boiler or as a power generation, or it can be used in the as a fuel for the vehicle called as compressed biogas. Now, secondly, the spent wash after the biomethanation process goes through a multiple effect evaporation. This is the section wise how I am explaining you. The multiple effect evaporation. Here we use the steam from the turbine outlet, primarily 3.5 bar steam, wherein the spent wash, the digester outlet is at 6% solid, and then we concentrate up to 30 to 35% solid. So this is the complete section wherein the concentration of the vinasse takes place. And then it goes to the dryer, wherein we use bagasse to make heat, and this heat source is used to convert the concentrated vinasse to pure powder. So this is the dryer. So this is, until and unless you don't have a proper drying system, that it's not possible to achieve zero liquid discharge. So this dryer plays a very critical role to attain zero liquid discharge. So what's coming out of this? It's you get potash from this. So this is the complete scheme of the how the dryer operates. How it operates. In the feed tank, the biomethonated vinasse, which is concentrated up to 30 bricks, it comes into the feed tank, and then we pump it into the spray drying chamber. What is the heat source for this? How can I remove this water from this? So what I use the bagasse in the furnace. There is an external furnace which we put some bagasse, we generate heat and pass it into the dryer, and in the dryer what it happens is, there is a rotary disc which specially designed for vinasse. It rotates at 8000 RPM, it's at top. So a mist is formed. When a mist is formed, the hot air comes in contact with the mist, so the mist will get evaporated out and only the solid will come at the bottom. So this green portion is the solid conveying line where the solid is collected in the silo. So in this complete process, you get the powder one side, and the other side you get the vapor which is vented out to the atmosphere. So this is the complete process of drying, how the concentrated vinasse is dried and the powder is taken out. So the powder is a potash rich powder. So like this is what the environmental outcomes from it. So complete handling is prevented. So this is a perfect route. Energy is captured as a gas, condensate becomes reusable water, solid residue becomes a controllable product. So complete zero liquid discharge route. So advantages of this technology: operating cost is completely less. Like presently you might be having a cost to dispose, the disposal cost becomes completely nil. So gas is recovered, many advantages are there. I'll show you this presentation in detail, so you can see in detail. So if required, I can give a case-to-case comparison also based on your complex. So every complex has its own advantages and disadvantages, based on the steam availability, based on the distillery capacity. So in India, with this concept, we have come up with 2018 was the first installation that was for 120 kiloliters per day ethanol plant. And then today, we have come up with 50 installation on this. So these are some list of installation with this route is followed. Environment clearance has been given by the government, and this technology is adopted by 50 plus references. These all are references purely installed by Raj Process. And Raj Process is the only organization who has came up with this technology and purely worked out on this technology. In India, there was a concept in 2013-15 wherein the spent vinasse was incinerated. The raw spent wash was incinerated. We came up with the concept not to incinerate the spent wash, rather recover the biogas and make fertilizer out of it. So at that time, people were very dicey because operating the biodigester was a challenge at that time. Then when today what we do, we are not burning the biogas in the boiler. We are making it as a CBG, compressed biogas. This gas is used in the vehicle as a fuel. So that's a good revenue. Like 10 times more revenue you get compared to incinerating in the furnace, in the incineration boiler. So these are some big distillery. You can see Vishwaraj Sugar, it's a 250 kiloliters per day on sea molasses. That means around 2000 meter cube of vinasse is being generated, and that is converted into potash and biogas. So these are some 200 KLPD Deccan Sugar. So these are some big distilleries with big capacities on sea molasses. That means the quantity of volume of vinasse is very high. So these are around 43 in 150 KLPD. So the reference comes up to 55, and this concept is booming in India very much. Not only in India, Africa is a major source wherein you have plenty amount of press mud. Press mud is a good source to make biogas, wherein you can purify the biogas and make it as a usable CBG, compressed biogas for vehicle. Fine, I'll just like to play 2 or 3 videos wherein you can get the complete clarification of the concept, what this CBG mean, what does the cascade look like. I'd just like to play this video. Raj, clean. So this is a plant on press mud. We consume daily 300 ton per day of press mud. and we make 12,000 kilos of CNG through this plant. So these are the digesters wherein we put the press mud, and we make biogas from it. Each digester 100 ton has been put, so total 300 tons. So these are the digester and the gas purification on the other side. Stop. Pause. So I'll just explain you how it is. This is the gas purification section. The blue part is the H2S scrubber, and the vertical tower in stainless in white is the CO2 scrubber, wherein we are removing the H2S and we are removing the CO2. So this becomes 98% pure methane, which is equivalent to CNG, what you fill it in the vehicle. So this is the complete gas purification section. So this plant is being set in 6 acres of land. So this is how the complex looks like. So I'll just show you in another video behind people how the press mud has been diluted. So this is how the press mud is unloaded at a point, and then it is diluted. Because press mud has 70% moisture, 30% solid, we want to convert it to 12% solid and remaining 88% moisture. So we dilute it once. So one time water is required because the water keeps on recirculating coming out from the digester. So it has been filled in this digester. This is the central CSTR digester. One is for vinasse and second is for press mud. The gas goes together to the gas purification plant. So this is the gas purification plant, and then we fill it in the cascade. It's a 500 kilo cascade. So now one last video of vinasse, 20 ton per day. Jakra sugar. So this is a 20,000 kilo purely on vinasse. This is how the focus over here is. This will be the future in Africa too, where India is almost covering every sector. Every sugar mill is planning for this concept. This is a 20-ton plant, 200 KLPD capacity distillery on molasses. This is same the H2S scrubber, CO2 scrubber, and the gas filling. This is how the cascade has been filled. This is a vehicle of 1500 kg capacity. So not ethanol is one part, but majorly potash and CNG is becoming a good revenue for the industry in India, distillery sector. That's why the distillery is booming in India, even though the ethanol is not getting much profit. CNG is the major source of income. So these are the digesters. This is the CSTR digester. And one last video of GM Sugar and Energy. This is a 15,000 kg, both same. One digester with vinasse. Yeah, this one. One digester is for vinasse, because for press mud the height needs to be very less. So these two are the on press mud. So gas from the press mud is taken out, from this vinasse has been taken out, and together it is being purified in the purification section. So this plant has almost got commissioned. This video was taken at the time of installation. This is the central agitator on the top, so that the gas yield will increase. So that is the main agenda to give the central agitator. This is the scrubbing section. Fine. So, so this winds up the complete presentation. Finally, to conclude, I just want to say ethanol is not only the main source of revenue. Potash from this vinasse, the biomethaneated vinasse, then converting into potash, and the CBG, biogas, is one of the major source of revenue. And parallelly with the press mud, you get biodigestate coming out. The raw biodigestate compared with this biomethaneated digestate, has the biodigestate post-biomethanation has a good revenue compared with the raw press mud. And the gas coming out, you can bottle it, purify and bottle it. That's it. Thank you. Thank you, everyone. Thank you.
Thank you very much, Binu. If any of you have any questions, please visit Raj. I encourage you to go to their stand and learn more of what they bring to the table. We've heard so many plans here in Africa to diversify, to become more efficient. Raj can help you be there, and I'm sure Binu and his colleagues will be glad to do a one-on-one with you and tailor to your necessities. Thank you very much, sir.
Thank you everyone, thank you.
Our next speaker is of particular value to the conference. So much has been spoken about Brazil. I don't think it takes rocket fuel science to figure out that Brazil's leadership role and their competitive advantage that they've gained in so many areas is something that we need to learn from. I at ISO have had the great experience to find Brazil what I call an open book. They're willing to share their experience. They're willing to show you how it's worked for them, the good and the bad. And I think that you need to extrapolate from everything they've done to bring to your equation what makes sense to you. This is not a one-size-fits-all thing. And